Why don't we proceed further and increase the consistency level to quorum? So naturally, we have to read from the fastest or preferred node or the pinned node. The coordinator will say, okay, that's fine. Okay, let me read from N3. But look what the client has told the coordinator. You need to read from quorum number of nodes. Let us assume our partition size is 50 megabytes. Well within the best practices, 100 megabytes, 50 megabytes, let's say. Forget about 50 megabytes. Why don't we take 10 megabytes, 10 MB? So I read 10 MB worth of data from N3. Quorum requires the coordinator to read from at least one other node. Naturally, if my replication factor is 3, quorum is 2, so I have to read from 2 nodes. Obviously, it's a given that I'm going to pay a currency of time. So I read from the fastest node, fine, fair enough. So who's going to be the next one? The next performing node. Right, so for instance, N3 is my pin node, so sure, I'll get the data from there. I need to figure out one more node who's next in line in terms of the ordered list of load information, right? I got to go out there and grab the data from there. One very interesting question at this time. Does it make sense to read exactly the same 50 MB worth of data from another node and transmit it over the wire network? Is that a good, efficient use of my networking resources? So if you really logically think about it, the answer to that question is no. Why should I transmit exactly the same data right over the network twice? Can there be an efficient model? That efficient model is sending a checksum or the digest. So what will end up happening is the fastest node returns back the full data set. The second node responds back with a digest. A digest is nothing but a hash. Now this hash has got nothing to do with partitioning. Is a checksum to say that I read 50 MB worth of data and here is this little checksum that I'm sending it back to you. So what does a coordinator now have? Coordinator has full data from one node and checksum from another node. The coordinator is also Cassandra. It also has exactly the same code as everybody else. So can coordinator create a checksum from the full data that it received? Absolutely. Now what do I have? I have two checksums. And now I compare. If the checksums match up, that means I know for a fact the two nodes that I selected to get the data from is matching. And I also optimize the network. So only 50 MB worth of data came through and then the checksum came through. Of course, the question is brewing in your mind. What happens if it doesn't match? I'm going to come to it. So what will end up happening? If the data is not matching, or rather the checksum is not matching, that means I know for a fact that the data these two replica nodes have is different. And why may it be different? It is possible that a replica node may have gone down and it would have missed the data. You remember in the put operation, if I have consistency less than all, I really don't care about the response from all the replica nodes, and maybe one node was down, it never received the data. So the data is different and hence the checksum is not matching. So what do I do next? Looking into the checksum, I have no way of telling what the difference is. Remember, it's 50 MB worth of data. The checksum will be hardly a few bytes, maybe. So how do you know? So the coordinator does a logical thing. It basically says, the checksum is not matching. So the replica node that send the checksum or the digest, the coordinator will reach out to that node again and say, hey buddy, I know you had given me the checksum before or the digest. It's time that you send me the whole data. Something has gone wrong. I have no idea what it is. I can't determine unless you let me know what you saw. So you reach out to that node again, and now what you have? 250 MB worth of data. Maybe it could be 51, maybe it's a little less. Who knows? There's a difference. And now what the coordinator has to do, go through each record and compare the timestamp. You remember at the time of putting the data, the coordinator uses its timestamp NTP. So that's how now the coordinator knows when it looks at 250 MB worth of data, what is the delta, what is the difference. It is possible that the data was there but stale. It is possible that the data wasn't there at all. And you know what the funny thing is? We were thinking the node that was sending the checksum, that node was essentially not current. It so turns out that the node that sent the checksum is actually current. The node that sent the full data was the stale node. Anything can happen, isn't it? Important thing is, I now have two full data sets that I can compare. And what do I do next? Once I figure out what the difference is, I fix the node that is not current. I am repairing the data. I am repairing the data at the time of reads. This process is called as read repair. And because the client is waiting, remember the coordinator is doing all of this hard work, the client is waiting. The client is blocked. Please note when I use the word blocked, it is not the whole client is blocked. It's not the whole coordinator is blocked. It is this operation is blocked. Cassandra is multi-threaded. This coordinator at this very moment could also be working on something which is working normally, multi-threaded environment, right? So when I say blocked, it is this operation that is blocked. This is called as blocking read repair. This is one of the ways in which data can be patched up, data can be fixed among the nodes. Please mark this, that were selected for the read operation. You might be thinking, wait a minute, replication factor was 3. This demonstration talked about N3 and N4. What about N2? What about it? I don't care because I said quorum. I told the coordinator explicitly quorum number of nodes. The coordinator will do exactly what it's told. It's a rule. So the coordinator will reach out to quorum number of nodes and it's going to figure out based on the data on those two nodes and respond back. Now, did you not pay the currency of time? You did pay the currency of time. What is the guarantee of receiving good data? 2/3. You know for a fact that when the coordinator responds back with data using quorum read, you know this is the data that exists in the 2 out of 3 nodes for sure. Whether it existed to begin with or whether it existed after a read repair doesn't matter. You know you're guaranteed to get this data from those 2 replica nodes. And if I were to extrapolate this to consistency level all read, that means Cassandra will reach out to all the replica nodes and fetch the data. Is it possible that there can be a difference? Absolutely. So much like how the data fixing happened between the 2 nodes, it will basically do across all the replica nodes. And if Cassandra succeeds to respond back at consistency level all, I know all my replica nodes has the latest and greatest data. But what's the downside? Time. And second, if your one node is down, consistency level read, a consistency level all read will fail. Much like how consistency level all put operation fails, read will also fail. The coordinator will immediately turn back and say, nah, I don't think I can achieve consistency level all. Replication factor was 3. Hey, I just figured one node is down. So I cannot do that. So again, much like how write was inversely proportional in terms of time and data availability, it seems like read is too.